Hi, I'm Reem Jarrar, and today I will present my term project for the Software Architecture and Design Patterns course. DriveShare, a peer-to-peer car rental platform. The platform allows owners to list vehicles and renters to search, book, communicate, and make payments. The project was implemented using Python, tkinter, and SQLite, while incorporating 6 software design patterns. So the goal of the project was to create a complete car sharing platform. Owners can list vehicles and manage pricing, while renters can search, book, watch vehicles, communicate with owners, and make simulated payments. The system also provides notifications and password recovery. Let's get started with the demonstration. Starting with the registration. The registration process requires users to create an account using email and password authentication. Additionally, 3 security questions must be configured. These questions are later used during password recovery. When registering, you can choose to be either an owner or a renter. After registrations, users authenticate using their email and password. The system used the singleton pattern through the session manager class to ensure that only one active session exists at a time. So if we first log in as an owner, this screen allows vehicle owners to create new listings. The builder pattern is used to construct the car listing object step by step before storing it in the database. After the information of the listing is filled, the owner will click the Add Listing button. The listing will be added to My Cars tab. Owners can manage their listings after creation. They may update prices and availability information by choosing the listing they want and enter the new price and click the Update button. These updates can later trigger watchlist notification for interested renters. We will talk more about that when we get to that section. So if we log in as a renter, we get a different interface where renters can search for available vehicles using location and rental dates. Only vehicles that satisfy the search criteria and do not contain booking conflict are returned. So here, the user searched for a specific location and a start and end date, and when they clicked search, they got one listing. The renter can reserve a vehicle for a specific period by choosing the desired vehicle and clicking the Book Selected Vehicle button. Before a booking is created, the system verifies that no overlapping reservation exists for the same vehicle. Another feature is the watchlist feature. This feature is implemented using the observer pattern. Renters can watch vehicles and specify a target price. When an owner updates the price and the target condition is satisfied, the renter receives a notification. So here, the renter chose one vehicle and selected the watch list price to be 70. Going back to that owner's account, they updated the price to be less than the price that the renter has inputted. So now it notified the owner that matching watchers were notified. Going back to the renter's dashboard, in the notification tab, they will get notified that the owner of the car they watch listed has updated the price, so they can go ahead and rent that car. The messaging system allows owners and renters to communicate directly. The payment functionality is implemented using the proxy pattern. The proxy validates the booking and user balance before forwarding the request to the payment service. So here the renter sends a message to the owner of the car that has listed the vehicle. And here we can see that that owner has received the message. And last of all, we have the password recovery. The password recovery process uses the chain of responsibility pattern. The user must answer 3 security questions correctly before the password reset is allowed. So, the user will enter their email and click on the Load Security Questions button. It will load the questions that they inputted when they registered their account. Then they would have to answer the 3 questions correctly and then enter a new password. It will only reset the password if they have answered the questions correctly. So that is the end of the demo. Let's continue with our presentation. The application follows a layered architecture. The graphical interface communicates with the application logic, which then accesses the SQLite database. The design patterns are integrated within the application layer. This UML diagram shows the major classes in the system. The application contains domain classes such as user, car listing, booking, message, and notification. Additional classes implement the required design patterns. The database contains 6 primary tables. Users store authentication and security questions. Cars store listings. Bookings manage reservations. Watch lists support notifications, while messages and notifications support communication. So now we're going to talk about the design patterns, starting with singleton pattern. The singleton pattern is used for session management. Only one active session should exist during application execution. Every screen accesses the same session manager instance to identify the current user. The builder pattern is used to create car listings. Since a listing contains multiple attributes, the builder constructs the object step by step while ensuring all required information is provided. So instead of creating a car listing with a long constructor, the builder sets each part step by step. After all required fields are provided, the build method creates the final car listing object and saves it to the database. The observer pattern powers the watchlist feature. Renters subscribe to vehicles by defining a target price. When an owner updates a vehicle price, all matching renters automatically receive notifications. This snippet shows the chain of responsibility pattern. The recovery request must pass 3 security question checks. If any answer is incorrect, the process stops. If all answers are correct, the user is allowed to reset the password. The proxy pattern protects the payment process. The renter does not directly access the real payment service. Instead, the proxy checks whether the booking exists and whether it has already been paid before forwarding the request. Moving on to the booking conflict prevention. This is the core logic that prevents double booking. The system checks whether an existing booking overlaps with the requested rental dates. If an overlap exists, the booking request is rejected. In conclusion, DriveShare successfully implements a complete peer-to-peer vehicle rental workflow. The system satisfies all project requirements while demonstrating 6 software design patterns integrated into a practical application. The final solution provides booking management, communication, payment processing, notifications, and secure password recovery. Thank you for listening. This was my presentation for the end of term project.